6-57. So we need, it says, use the ideas in 6-56 to help you solve the following equations. So I have log of 10 equals log of 2x minus 3. That's for A.
I just need to tell on B.
Oh, you need B? Okay. So for letter B, we have log 25 equals log, a quadratic, 4x squared minus 5x minus 50. Oh, okay. So this one's nice because it's like two problems in one, and all teachers love that. So you might have learned from the problem previous to this that if these are the same base, they're both base 10, you can just set these arguments equal to each other. So this isn't really a problem about logarithms anymore. This is about factoring. Did I write it down correctly? Yes, I think I did. So are you okay with that, what I have so far? Yeah. Because these logs are the exact same thing, then I can just set the arguments equal. So then I got to try to factor this thing. So I want to get a 0 on one side of the equal sign. Oops. So 4x squared minus 5x minus 75 is equal to 0. So you'll notice there's nothing nice for me to factor out, and this doesn't have a 1 in front of the x squared, so I can't really use any shortcuts that I have. I'm just going to go ahead and do my diamond problem. Now, I don't know if you guys know this, but a lot of times you guys you're looking for something that multiplies to make this number over here, the constant, but that's because oftentimes there's a 1, there's no number in front of the x squared, except for an invisible 1. So you just put this number up here. But you have this 4 here. So what you're really going to put up here is 4 times 75. I know.
300.
Is it 300? Negative 300? So we're looking for something that multiplies to make negative 300 and adds to make negative 5. And I'm a big fan of factoring, so I'm going to try to factor it. If you didn't want to bother with any of this factoring, all you do is just get your quadratic formula out and just plug the numbers in. I'm going to at least try, because I know that 30 times 10, if I made something negative, maybe that could work. Maybe 15 and 20. Hey, 15 and 20 maybe. Is 15 times 20 300?
Yeah.
Okay, so I just start trying stuff, and then if I make the 20 negative, see how it didn't take me very long to get it? And then I'm going to get out my area model, because at this point some of you might say, oh, well, it's x plus 15 and x minus 20, but that's not true because this 4 that's in front of my quadratic throws everything off. So you have to do everything the long way. Luckily, that's not always the case where you have a 4 there, but you're gonna have to just kind of do it the long way. Okay, so then my two numbers that I found were 15 and negative 20. And then I just go ahead and do that thing like I put something times something. It's the area model. So that times that makes what's inside the box. And then 4 times negative 5. Right? And then this has got to be a 15. Hopefully 15, let's see, is it going to be positive? So hopefully 15 times 5 is actually 75, is it? Yes. Okay, so this seems to work. So now I've got this all factored, and if you didn't like the factoring, it's okay. You can just use quadratic formula on it. I have a 0 here, though, so I'm going to use 0 product property on it. So x minus 5 equals 0, so that gives me x equals 5. And then this one, I could do it in my head. It would probably be like negative 15/4, but I'll show it. 4x plus 15 equals 0. I'm setting each of these two factors equal to 0. That one I just did it in my head. So, minus 15 on both sides. Some of you guys can probably do it in your head, and some of you maybe not. Oops, that's a 15. So x equals negative 15/4. So I got two different answers for x, and then I look back and I say, what started me on this big long journey? Well, I was looking at a logarithm problem. So I want to make sure there's some things that aren't allowed to happen with logarithms, and we already kind of learned a little bit about you can't have like a negative base or 0, and then we don't want this argument here to be negative either. So I want to, or 0, so we just want to go ahead and plug these in. Like if I plug in a 5 here, is that going to give me some problems? 4 times, that would be 25 if I go 5 squared. 4 times 25. That's 100 minus, oh, I better just do this here. I'm going to do it, I don't want to mess it up. I want to plug in my two answers here to make sure that I don't make anything negative. So if I plug in my 5, that gives me 100, I think. Minus 5 times 5 is 25. Does this give me a nice positive answer?
Yes.
Yeah, so I'm going to say that yes, I've checked it. This one's going to work out for me as a solution. Negative 15/4. Well, boy, I guess I got to do this math. Minus 50. So that's for, I don't know, what's 15 squared? 225?
56 1/4, both of them.
Oh, these two?
No, the 4 squared.
What?
The 4 and the negative 15/4 squared.
Yeah? Oh, okay, well, I'm almost there. Okay, so I'm just going to do this. So 225/4, and is that what you're saying is that number that you just said?
Yeah.
225 divided by 4? Yeah, he said that was about 56. So this is 56.25 right here. And then this thing is going to be some positive number. Hey, do I have to do the rest of this?
I think you just gotta find out what x is.
Well, I found x, but you have to check these because if you get a solution and you plug it back in here and it gives you a negative or a 0, then you're going to throw that one out and say it's an extraneous solution. So once you find what x equals, you have to check it back in the equation. I checked my 5 and it worked. This one, I'm thinking that 56 is a bigger number than this negative 50, right? 56 is bigger than 50. And then this thing, whatever it ends up being...
No, it's going to be negative.
Oh, it is going to be negative?
It is going to be, I can just tell.
Well, that's a negative number, and that's a negative number, though. You know what I mean? So wouldn't it be positive? 15 times 5 is 75 divided by 4. So that is plus 18.75 minus 50. That makes a positive. So I think we got two answers to this one. Both of the solutions that we got actually work. Sometimes that's not the case. I don't know if you guys have come across that. Has anyone ever come across the case where you find out what x is, and then you plug it in, and maybe one of your x's, maybe you got two x's, but one of them didn't work? Yeah, some people have seen that. So on this problem, though, we checked them both. The answer is x equals 5 and x equals negative 15/4. Let's see, how do we turn it off?